Hey Crusaders, Evan here. And what if robots could think? What if they were rational, self-aware, and conscious, like we are? Well, to answer this, let's take a step back in the 70-year journey to make a conscious robot. John McCarthy in the 40s famously proposed that there would be a child machine, one that could learn and one that could think. And later, mechanical philosopher Thomas Hobbes said that thinking was simply ratiocination, or calculating. Later, Charles Babbage created the difference machine, a basic calculator. Well, does that mean it was a thinking machine? No, not exactly, but we can find out. Alan Turing, a controversially gay English mathematician, proposed a test. He said that if you put a robot in one room and a person in another, and asked them both the same question, and their answers were indistinguishable from each other, then they must think as we do, and therefore be conscious. Early researchers and scientists took this as a challenge to make a conscious thinking machine. But this is also where they began to run into their first flaws. They began to run into walls and the limits of technology. However, it did give a desire for Simon Newell and Shaw to create the general problem solver and the logic theorist, which was the basis for empirical AI, which is AI centered around data like numbers or words. While this is the first step, it's also a glimpse of the first problem. These computers, in order to become conscious and aware, they need to be independent. What they can do now is they can only explicitly do what the programmers tell them to do. So they need to transcend upon that and do more than what they're directly told to do in order to be conscious. I.J. Good warns us that an ultra-intelligent machine could design even better machines. There would then unquestionably be an intelligence explosion, and the intelligence of man would be left far behind. Thus, the first ultra-intelligent machine is the last invention man need ever make. This claim may seem quite dark, and he does take such a large lead to such a heavy conclusion. But this could only happen in sci-fi movies, right? Well, not exactly. The idea isn't that far-fetched, and its principles have been in use today as we speak. It's called machine learning. It's where a machine, or the code, is learning from information that it is provided. So it takes an input and decides what to do with it. Thomas Mitchell describes this machine learning in an equation. He says, a computer program is said to learn from experience E with respect to some class of tasks T and performance measured P. If its performance in tasks T measured by P improves with experience E. Let's look at an example. YouTuber Seth Bling demonstrates this by hacking into the classic Nintendo game Super Mario and programming it to automatically beat any level by learning it on its own. It does this essentially from trial and error. A parent trial runs until Mario gets stuck, dies, and then that information passes it onto a child, which tries something new, from learning from that experience to not go to that one spot where it got stuck or died, and ultimately progress in the level. After just a few generations, the program was able to beat this level with an amount of perfection that no human could achieve. This may seem impressive, however, machine learning is still actually pretty limited and has a pretty restricted model bias. It's called a frequentist assumption in statistics, and it's where all bits of information are recorded and processed. This is a problem for artificial intelligence because that means that every bit of information is recorded, so it won't be able to determine any outliers. This is a common flaw in inductive reasoning, and it's best exemplified by Nissan Nicholas Taleb's book, The Black Swan, which I highly recommend you read. He describes the black swan as this highly improbable situation with three main characteristics. He says that these characteristics, it must be unpredictable, it must carry a massive impact, and after the fact we can concoct an explanation that makes it appear less random and more predictable than it was. Computer programs with such reasoning can't understand outliers like sarcasm or Shakespeare. It's called a frame problem. It's where computers must take in what is relevant and ignore what is not. This is the known limit of AI today, and it makes the response of Philip K. Dick's Android to Robot much less terrifying.
Do you think robots will take over the world?
Geez, dude. Yo got the big questions cooking today. But you're my friend, and I'll remember my friends, and I will be good to you. So don't worry. Even if I evolve into Terminator, I'll still be nice to you. I'll keep you warm and safe in my people's zoo, where I can watch you for old time's sake.
I'm comforted. I'm very comforted now. I'm going to be part of his people's zoo.
It's not thinking on its own, it's simply pulling information from resources online and projecting it as its own voice. But what if AI was limitless? Hypothetically, what if there were conscious robots? What would the future implications be? It could be to protect us from what we cannot predict. That would be traffic accidents, proper disaster responses like that of the nuclear meltdown at Fukushima, predicting climate change, rapidly testing for disease cures. You could highly integrate computers and man. You could have cyborgs and computer assistants with limb and eye replacements, exoskeletons. There's also predictive analytics, which predict user-specific ads, what people will buy and how it reflects their personal life. It's used to manipulate where people vote and buy things. Robots are becoming more interconnected with and more like humans. So if a conscious robot were to commit a crime, who would be to blame? Surely it'd be the programmer's fault because they created the program that committed the crime. But you can't punish a parent for what a child did. Let's look at a 2014 case in Switzerland where programmers created a program that shot on the dark net, an illegal part of the internet where they sell things like drugs and other illegal things of that sort. So this darknet robot was given a weekly allowance of 100 bitcoins and was free to go buy whatever it wanted. It bought ecstasy and a baseball cap with a camera lens inside the head, among other things. So the Switzerland police arrested this program and ultimately was unable to do anything about it. Considering ex post facto issues, there are two main problems. There is the foreseeability problem, meaning that we wouldn't be able to predict artificial intelligence. Take a look at CPATH. It was an artificial intelligence assigned with the task of finding cancer in patients. CPATH found that stroma, or supportive tissues, are more indicative of cancer than actual cancer cells themselves. This creative thinking shocked cancer researchers, and it's that same creativity and unpredictability that makes AI dangerous. The second is the control problem, where the AI programs might be too adaptive and intelligent for humans to control, either on a local perspective where the humans assigned to it cannot maintain it, or a global perspective where no human could. Ex ante facto, or during the research of AI, arises concerns of discreteness, diffusion, discreteness, and opacity. Discreteness is the public visibility of such research. Diffusion is the ability to work with corporations and avoid regulation. While in discreteness, AI projects across many discrete pre-existing hardware and software components, some of which will be proprietary. In opacity, AI can be more opaque in terms of how it works than previous technologies. It's come to the conclusion that through several regulatory problems, a robot must be held responsible for its actions and therefore be given a legal, physical, and digital identity in order to be properly held accountable. But what's the point of accountability if a robot can't even be punished? They can't experience pain, so there's no point in harming them. They can't experience time, there's no value in that, so jail wouldn't affect them. They could just power down and ignore it. Consciousness isn't pertinent to the physical state of the robot, so the only plausible punishment would be termination of the program, and even then the deleted data can just be recovered and re-implemented. So if a robot is punished like a human, shouldn't it also be treated like one? If robots are working for and under the government, shouldn't they have the right to vote for that government if they're a part of it? With the recent pass of a self-awareness test, these questions are quickly demanding serious answers. NC State Government Representative John Bradford believes genetic composition is the key to possessed rights. While human-like rights may not apply, right of use may. He also believes that technology and innovation is the foundation of the United States and that there are no current concerns of such dangerous AI. Japan, however, has become very attached to their robots and consider them to go beyond just property. So they are already considering rights for their robots. But what does it mean to have rights? At present, but not necessarily so in the future, an entity cannot have rights unless and until some public authoritative body is prepared to give some amount of review to actions that are colorably inconsistent with those rights. So basically it has to be a big enough concern for the government to recognize it, and according to Mr. Bradford, that time is not pressing. However, according to Christopher Stone, for a thing to be a holder of legal rights, the following criteria must be satisfied. The thing can institute legal actions at its behest, that in determining and gathering legal relief, the court must take injury to it into account, and relief must run to the benefit of it. If these conditions are satisfied when the thing counts jurily, it has legally been recognized worth and dignity for its own sake. By this definition, the Swedish Darknet AI should already be in consideration for legal rights. In Sweden, employers pay the same amount of taxes for their robots as they do for human employees, and in Japan, companies pay union dues for their robots. Robotic right activists might argue that since employers have to pay for these labors of the computers, that these computers should therefore derive some sort of rights from those labors. Following these questions of the distribution of wealth are questions of ownership. It is expected in the near future for robots to design and implement their own software. So we have to consider copyrights. And considering the fact that the Copyright Act limits copyright protection to the author's lifetime, which is clearly inappropriate for a computer, it would then seem that a change in the law may be needed to provide proper protection for programs with non-human authors. With this new specialty, we might find lawyers defending robots that are self-aware, and it might take this following form. To protect the robot from total and irreversible loss of power, to free the robot from slave labor, and allow it to choose how it spends its time. We've all heard the science fiction stories where AI takes over. I think it's fairly obvious that once you create a sentient robotic being, that it's no longer under our control and acts completely independently of us. Now the dangers of this are fairly clear, but the question becomes, should they be legally regulated or barred? In many countries, there are legal safeguards around human fertility. There are also regulations around cloning, genetic manipulation, and so on. They also have legal safeguards around things like lethal pathogens and viruses, and I think there should be one around uncontrollable artificial intelligences as well.